NASA has recently announced an innovative and strategic approach to exploring Venus, particularly in light of intriguing discoveries that suggest the potential for life on this enigmatic planet, dating back to the 1960s. The fundamental method for searching for extraterrestrial life in the universe involves the detection of unusual gases in a planet's atmosphere, specifically, gases that are closely associated with biological processes. This approach is regarded as one of the most reliable techniques in the field of astrobiology, providing scientists with crucial insights into the potential for life beyond Earth. In the 1960s, Venus was predominantly viewed as an extremely hostile environment. Its surface temperature can reach a staggering 900 degrees Fahrenheit, approximately 475 degrees Celsius, and the atmospheric pressure is about 92 times that of Earth, akin to being nearly a mile underwater. Furthermore, the atmosphere is filled with corrosive clouds of sulfuric acid, making it a particularly challenging location for any form of life as we know it. While the United States was primarily focused on Mars, which seemed to offer more promising conditions for exploration, the Soviet Union took a bold and somewhat unconventional stance by launching a series of missions to Venus. This initiative underscored the intense competition of the space race during the Cold War, where technological advancements were not only matters of scientific interest but also of national pride and prestige. Neil deGrasse Tyson, a prominent astrophysicist and science communicator, has significantly contributed to our understanding of these Soviet missions. He emphasizes not only their achievements, but also the numerous challenges they faced in their quest to explore Venus. The Soviet space program, known as Venera, began its ambitious journey in 1961 and continued until 1983. During this period, the Soviets dedicated substantial resources to studying Venus, launching a total of 28 spacecraft, 13 of which successfully entered the planet's atmosphere and managed to land on its surface. Despite the initial setbacks, such as the failure of Venera 1 to transmit any data after it passed Venus, the subsequent missions began to yield increasingly valuable information. Venera 4, launched in 1967, was particularly notable for being the first spacecraft to successfully transmit data from the Venusian atmosphere back to Earth. It managed to gather atmospheric data for about 90 minutes before succumbing to the extreme conditions that characterize the planet. This mission revealed alarming levels of carbon dioxide, thus confirming that Venus's environment was highly inhospitable to life as we understand it. As the Venera program progressed, missions like Venera 5 and Venera 6 only reinforced the conclusion that Venus's atmosphere was extraordinarily unforgiving. The findings indicated not only the extreme temperatures but also the suffocating atmospheric pressure and the presence of toxic gases, all of which posed significant challenges to any potential forms of life. Despite the disheartening results regarding the possibility of life on Venus, classified documents have revealed a fascinating shift in the Soviet Space Agency's focus after the early missions. Instead of completely abandoning the search for life, the Soviets began to explore the potential for microbial organisms existing in the more temperate upper layers of Venus's atmosphere. This pivot in focus reflects a growing understanding of the planet's environment, and the implications for astrobiology, as well as the realization that life might not be confined to surface conditions. In recent years, the scientific community's interest in Venus has surged once again, particularly following the discovery of phosphine, a gas often associated with biological processes, detected in the planet's atmosphere. This groundbreaking finding has revitalized discussions and debates about the possibility of life existing in some form within the planet's clouds. While the idea of humans living on Venus remains impractical due to its toxic atmosphere and extreme conditions, scientists are now more focused on examining the planet's geological history and atmospheric evolution for clues about the potential for past life and any extraterrestrial interactions. One of the most compelling developments in this renewed interest has been the reanalysis of images captured by the Venera 13 mission, which successfully landed on Venus in 1982. Researchers discovered 3 distinct objects in the high-resolution images that appeared to exhibit characteristics of living organisms. One object seemed to respond to changes in heat or pressure, suggesting it was not merely a rock or mineral formation. Another object took on an elongated shape that changed over time, raising questions about its nature. Most intriguingly, the appearance of an unusual creature resembling a scorpion sparked widespread speculation about its origins, whether it was a native species that adapted to the harsh conditions of Venus or possibly an extraterrestrial life form from elsewhere in the cosmos. The resurgence of interest in Venus, and its potential for hosting life has led to ambitious plans for future missions. The Russian space agency, Roscosmos, has announced significant goals to explore Venus more closely by 2029. This renewed commitment underscores the ongoing fascination with this mysterious planet and the desire to unravel its many secrets. It also highlights the importance of international collaboration in space exploration, as nations increasingly recognize the value of sharing knowledge and resources in the pursuit of understanding our universe. As scientists continue to study Venus, they remain hopeful that advanced technologies and innovative exploration methods will one day lead to significant discoveries about the potential for life beyond Earth. The combination of historical data, renewed interest in astrobiology, and cutting-edge research positions Venus as a critical focus in the ongoing search for extraterrestrial life. This endeavor not only seeks to answer fundamental questions about our place in the universe but also enriches our understanding of the various conditions that might support life, challenging us to rethink what we consider habitable. Ultimately, the exploration of Venus serves as a reminder of the complex interplay between science, history, and the relentless human spirit to explore the unknown. The future of Venus exploration promises to be an exciting chapter in our quest to understand life beyond our home planet, as we continue to push the boundaries of knowledge and discovery.